Hi everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Today I would like to explain about few topics which are uh, given in question bank. So I want to discuss on question bank questions, especially mainly on heat exchanger topics. Okay, first we'll see. First topic is the classifications of heat exchanger. This is the question given in question bank. How are heat exchangers are classified? Why is counterflow heat exchanger is more efficient than a parallel flow heat exchangers? And we can see a few more questions like what are the classifications of heat exchanger? Next, what are the different applications of heat exchanger also? In this video, we'll address those questions. First of all, we'll see uh, introduction about the heat exchanger. We know that heat exchanger is a device which is used to enhance the heat transfer rate. Heat exchanger is defined as the equipment which transfers the heat from a hot body to cold, hot fluid to cold fluid. So here heat transfer takes place between two fluids, one hot fluid to cold fluid. So it is the just like device, it can improve the or enhance the heat transfer rate. Now we'll see types of heat exchangers. There are so many types of heat exchangers based upon the construction, based upon the flow type. So we'll see different types of heat exchangers. So first one is the direct heat exchanger. Direct heat exchanger. So next one, we'll see one by one what is direct heat exchanger, how heat transfer takes place between the fluids. So next one is the indirect contact heat exchanger. So first one is the direct contact heat exchanger. Second one is indirect contact heat exchanger. So third one is the regenerators. So regenerators are recuperators. We'll see what are the regenerators. So under which what are the types of heat exchangers we'll see. So what is recuperators? Under which what type of heat exchangers will be covered in this under this one? We'll see those things also. So recuperators mainly in parallel flow, counter flow, and the cross flow also we'll see. So we'll see one by one. Okay. Compact heat exchangers also we'll see, and next to cell and tube type of heat exchangers also we'll see. So first one we'll see the direct contact heat exchanger. It means direct contact means the two fluids physically mix with each other. Then heat transfer takes place from hot fluid to cold fluid. Okay. So in direct contact heat exchanger, heat exchange takes place by direct mixing of hot and cold fluids. Involves heat transfer between hot and cold streams of two phases in the absence of separator valve. Here there are two types of the phases. One is the steam vapor position, another one is the liquid portion. Okay. So heat transfer takes place from the higher fluid to or hot fluid to cold fluid, from steam to fluid, liquid fluid. Okay. Here you can see. So here steam enters, condensation occurs also. So this one is the vapor, this one is the liquid. So heat transfer takes place between vapor to liquid. So by mixing with each other. So this one is the direct contact to heat exchanger. Otherwise, one more thing, this is the container in which we can add hot fluid directly, cold fluid here also directly. Hot fluid, cold fluid entering, hot fluid entering. Okay. So here, so finally both the fluids mix with each other, then heat transfer takes place from hot fluid to cold fluid. So this one is the direct contact heat exchanger. Now we'll see indirect contact heat exchangers. These are very important and, heat exchangers. So in this type of heat exchangers, the transfer of heat between two fluids could be carried out by transmission through the wall which separates the two fluids. Okay. So you can see here inner pipe and outer envelope or outer pipe. This one is the hot fluid enters, hot fluid entering, hot fluid leaving, cold fluid enters, cold fluid leaving. So heat transfer takes place from hot fluid to cold fluid by wall which separates the two fluids. Indirect contact heat exchangers keep the fluids exchanging heat separate by the use of some tubes or plates and different. Here, both the fluid doesn't mix with each other, but separated by some pipes or tubes. But heat transfer takes place through one fluid to another fluid by the wall which is separating the both the fluids. Okay. So this one is the indirect contact heat exchanger. We can see examples of indirect contact is nothing but parallel flow, counter flow, cross flow. All these belongs to indirect contact heat exchangers. Second one is the regenerators. What is the regenerators? So we'll see in this type of heat exchangers, hot and cold fluids flow alternately through the same space. First we'll send hot fluid, then we'll send the cold fluid. So when the hot fluid enters into that space, heat is taken from the hot fluid. When we send the cold fluid, the heat is taken from that space to that cold fluid. So for example, IC engines and gas turbines here, we'll see. Suppose any pipe or any cylinder. Okay. So first of all, we'll send hot fluid. Then automatically the container, this space will be heated. When you send the cold fluid, that heat will be taken by the cold fluid from the same space. Okay. This is nothing but regenerators. So there are so many applications of the regenerators. So you can see in IC engines, same space, that cylinder that was sometimes filled with the hot fluid next to cold fluid. Gas turbine also you can see. Next one is the recuperate heat exchangers. This is the very most common type of heat exchangers in which hot and cold fluids do not come in contact with each other, but separated by the wall. Heat transfer takes place from the wall, which separates both the fluids. Okay. So this is not indirect contact heat exchanger type. You can see here. We will see this is the regenerative type heat exchangers. Already I told that one. Same space will be occupied by both the fluids alternately. Okay. So heat is transferred from the hot fluid to cold fluid through that space. So next to already recuperators. So under which we will see three main types of heat exchangers. One is the parallel flow heat exchanger. Second one is the counter flow heat exchanger. Third one is the cross flow heat exchanger. First of all, we will see parallel flow. What is parallel flow heat exchanger? Or next, what is counter flow heat exchanger? In this type of heat exchangers, so it means in the parallel flow or counter flow heat exchanger, hot and cold fluids move in the same. So it means in parallel flow heat exchanger, we will see this one is the parallel flow heat exchanger. The corresponding graph of this parallel flow heat exchanger you can see here. This one is the counter flow heat exchanger. The corresponding graph related to counter flow exchanger you can see here. So we'll see first of all parallel flow heat exchanger. So in parallel flow heat exchanger, both the fluids enters one side and leaves the another side. It means both the fluids, hot and cold fluid, move in the same direction and parallel to each other. Move in the same direction. Here, hot fluid enters, hot fluid leaves. Cold fluid enters, cold fluid leaves. So both the fluids, hot and cold fluids, move in the same direction and parallel to each other. So this type of heat exchangers is nothing but parallel flow heat exchanger. So here we can see the graph. Hot fluid temperature is very high. So this is the H high. Hot fluid enters. Cold fluid enters at one side. Hot fluid leaves and cold fluid leaves at another side. Okay. So the difference between the hot fluid and cold fluid entering, that is the delta T1. The difference between the hot fluid and cold fluid leaving, that is the delta T2. So this is the graph which is related to parallel flow heat exchanger. Now we'll see counter flow heat exchanger. It is also very similar to parallel flow heat exchanger, but both the fluids are parallel to each other, but direction is different. So both the fluids move in opposite direction. Here hot fluid enters, THI enters, hot fluid leaves. Here cold fluid enters in this direction and cold fluid leaves here. Okay. So here if you observe the graph, here hot fluid enters and THA, cold fluid leaves. Here hot fluid leaves and cold fluid enters. Okay. So here you can see the difference. Here delta T1 is nothing but hot fluid entering minus cold fluid outlet. Delta T2 is equal to hot fluid outlet minus cold fluid inlet. Okay. So this is the just indirect contact type or recuperated heat exchangers. Okay. So in which both the fluids are separated by wall and heat transfer takes place. The wall which is separating the both the fluids. Okay. So parallel flow means both the fluids are parallel to each other and flow in the same direction. Counter fluid heat exchanger, both the fluids parallel to each other but opposite direction. That flows in opposite direction. So next one is the cross flow heat exchanger. Cross flow heat exchanger. In the cross flow heat exchanger, we have 90 degrees intersection of the fluid direction. So one fluid flowing like this one, another fluid flowing 90 degrees to the direction of another fluid. So if you consider this is the hot fluid, this one is the cold fluid. Okay. So perpendicular to each other. Here this type can include many channels of tubes. Okay. So same cell, different tubes. Here different cells and different tubes. Here cold fluid is the mixed fluid, but hot fluid is the different fluid which is passing through the different tubes. Okay. Here one fluid is the mixed, which flows the tube, not tube, the cell. Okay. So one fluid is unmixed, which is flows through uh, these different tubes. Okay. Here both the fluids are different, unmixed. There are different cells of the main different sections of cell. So here both the one fluid enters through tubes, another fluid enters through this cell type construction. Okay. Here both the fluids are unmixed. Here both the fluids, one fluid unmixed, another fluid is the mixed. So this type of cross flow heat exchangers we can observe in uh, different, mainly we can see this type of exchangers in automobile radiators. Okay, so cross flow heat exchanger means in this case, each of the fluid flow a prescribed path and is unmixed as it flows through heat exchanger. As the temperature of the fluid leaving the heater section is not uniform. Okay, so hot fluid flows in the separate tubes. There is no mixing of the fluid streams. Cold fluid is perfectly mixed. So this is the completely unmixed both. Here one fluid is mixed, another fluid is unmixed. The temperature of this mixed fluid, cold fluid, will be uniform across the section. So here just like cold fluid is the uniform temperature, hot fluid temperatures are different. Okay. Here cold fluid and hot fluid both are different temperatures, not uniform. Okay. So that one is the automobile radiators. So this is the cooling unit of refrigeration systems. Okay. So here, so one is the unmixed, another is mixed. Here both the unmixed. You can see. Next to cell and tube type heat exchanger. So this is here also cross flow you can observe. So through the different pipes, one type of fluid will move, will pass, and perpendicular to that one through cell. So another fluid, cool fluid will flow. Okay. So this type of heat exchangers, one of the fluid moves through the bundle of tubes enclosed by the cell. The other fluid is forced through the cell. Okay. It moves over the outside of the outside surface of the tubes, like this one, outside surface of the tubes. Okay. So one is mixed, another one is unmixed. Here you can see different two types of cells and the different tubes, many number of tubes. Here one cell, many number of tubes. You can see two cells, many number of tubes also. So this is an example of cross fluid exchangers. You can see. Okay. So here parallel flow and counter fluid exchanger. This one is the counter flow. Uh, this one is also counter flow. So this is the cross flow. This one also cross flow. Okay. So this is parallel flow. So both the fluids in the same direction. This is the one fluid is one direction, other fluid is in opposite direction. So this is the counter fluid exchanger. You can see examples. Next one, counter flow heat exchanger is efficient than the parallel fluid exchanger. Okay. So the maximum amount of heat or mass transfer that can be obtained is higher with counter current than co-current. It means parallel exchange. So parallel exchange, because counter current maintains a slowly declining difference or a gradient. Okay. So usually temperature or concentration difference, that is called. So gradient or declining difference is very slow in counter flow heat exchanger, but in cross flow heat exchanger very very high. So counter flow heat exchanger is very efficient compared to parallel flow heat exchanger. We will see different types of the applications. You can see this type of heat exchangers in uh, architectures and climate engineering also, greenhouse effects. That time also we can see this type heat exchangers in human body, exchanging of heat from body to atmosphere, atmosphere to body. So in this biological system also we can see the applications of heat exchangers. Next to cooling techniques and the evaporation of coolings, laser cooling, magnetic cooling, and the food processing system, radiator systems in many areas in automobile system. In many areas you can see the applications of heat exchanger. Okay, so these are the just to, one of the main question which is related to heat exchanger. Define heat exchanger and classify different types of heat exchanger, and why counterflow heat exchanger is very uh, uh, efficient than the parallel heat exchanger. Okay. So these are the different textbooks. We can refer these textbooks. Okay. Thank you listening to this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.